All right, welcome to our video on lists and list traversal. We want to take some time to go through some new blocks that we're introducing in this unit that help us to declare multiple values. Up until this point, we've had experiencing taking sprites, asking them to move, looping their behaviors, so perhaps their movement is continuous. We've looked at conditional logic like if statements, if else statements. It's time to advance our programs by using lists. And what are lists? Objective 1 for our learning right now, define lists. A list is just like any other variable. Recall that when we go to make a variable, say I make a variable called counter, right? I can use these orange colored blocks to set counter to some number. And when I do that, I can see that the variable appears on the stage. We're able to change its value. I can choose to set its value to a specific number. I can choose to keep incrementing that number. This works very well if we have 1 or 2 or 3 things that we'd like to track. Variables are useful for this. But sometimes what we want is a great many variables. And if we want that, we're going to do something called a list. A list is a collection of variables, just like any other variable. It can handle different values. It can handle numbers, both whole numbers and decimals. It can handle words. It can handle true-false values. We call these the Booleans, right? So if you want something to be true or false, that can be contained in a list as well as you want. And there's actually a few other things that you can do with a list, but we're going to save those for a more advanced video. If I want to set up a list, what I need to do is create a new variable and assign a list to that variable. Here's what this looks like. Let's say I want to make a variable and I'm going to call it Seahawks. Whoops, if I can spell. Seahawks, there we go. And in it, I'm going to go ahead and put the names of all my favorite Seahawks. So I will ditch that. We'll say, all right, set Seahawks to. Now I could just say Wilson, obviously, the legend, or I could assign more than one value to this thing. I could say Wilson, Wagner, Earl Thomas still looms large in my heart. I know that was a traumatic end, but that's not what this video is about. KJ, Clowney, right? So you've got, I'm obviously leaving out a ton of Seahawks legends, but that's who's on my mind at the moment. When I click this set button, setting my variable to a list, we see what appears on the screen is different than the other variables we've worked with so far. The single variable has just one value, but as I elected to put multiple things in this list, we can see them all here. An important thing I want you to take note of, note the number on the left-hand side of all of my values. This term is called an index. And the way an index works is it tells you where you are in the list. So if I want to access a particular element, I have to use its index. For example, let's say I want to get the second index for some reason. By the way, this is a new symbol right here, we should notice. We've observed all of our inputs look like, here's a rectangular input, means it can be anything, number or word. Here is a rounded input. This means that we're expecting a number here. We wouldn't want to change a variable by a word. That doesn't make sense, but we can change it by a number. This new input symbol, which I jokingly call the Hamburger, is all about using a list as an input. So if you see this, I can't provide a number, I can't provide a word, I can't provide a Boolean true-false value. It's got to be a list variable is what we're looking for. Or I guess, you could drop just like a list straight into it if you wanted, but I think it's going to be more useful to use a list that you've saved at some variable location. All right, so here we go. We say, hey, go get me the second item of Seahawks. When I click on this, it says Wagner, which makes a lot of sense because Wagner is at location 2. He's at index 2. All right, so what do I do if I want to change a list? Well, you'll notice the light orange blocks are all about declaring variables. The dark orange blocks are all about manipulating lists. There are a lot of blocks, many of which we're not going to get to in this class, but let me go through some of the super important ones. All right, so obviously I have missed out on a bunch of Seahawks that are super important. So let's fix that. I'm going to say add to Seahawks. Remember, I got a hamburger here. Got to feed a list to the hamburger. Them's the rules. Who is another Seahawk that is hugely important? Let's go with Carson. Carson, that guy's amazing. When I click this add button, the program is going to go look at the list and say, how full am I? What was the last index I used? When I go to add something, I'm going to go add it to the next available index. And every time I click on this button, it just keeps adding and adding and adding, right? All right, well, maybe I've decided, oops, Chris Carson, he's not been cloned as far as I can tell. We need to get rid of him. Let's go ahead and delete the last item in the index, or the last item in the list, excuse me. And I'll delete Chris Carson that was at location 8. I'll delete Chris Carson that was location 7. All right, now this looks very reasonable. Let's say if instead of, go ahead and add an extra Chris Carson back, rather than deleting, I'm just going to go ahead and say, you know what, I know a real player who exists. I'm just going to go ahead and say, replace the last item of Seahawks with, who else is good right now? Let's go with, boy, I don't know why this matters so much. Disley. Will Disley. Man, that guy's pretty amazing. Sad that he's hurt. All right, so when I'll lowercase him just so that we can be consistent. All right, so when I click this, rather than add or delete, we replace the last value. So these 4 commands right here make up the basics of using a list. You can create a list, set some values. By using these arrows, you can decide how many values we start with. You could start with many. You could start with few. It's totally acceptable to start with an empty list and build from it. We do that all the time. And then you can add, delete, and replace as you go. Okay, so we've covered defining lists. We've covered how to add, remove, and change. Let's talk about how to traverse a list. So what does that mean to traverse a list? The idea behind traversal, here's your next vocabulary word. Traversal is visiting all items in a list. It's typically done from the first index to the last index. And sometimes we are just what I would describe as reading, meaning we just want to look at information. And sometimes we are writing, which means we want to change the list in some form. Reading is much more easier to do than writing, and we'll talk about the difference between those for a little bit. All right, I'm going to turn my counter variable off because we don't need it anymore. All right, so we're looking at our list of Seahawks. Oops, that accidentally has an empty spot on the roster. Bloop. We'll go ahead and fix that right there. All right, so how do I visit every element? Well, hopefully you're thinking, gosh, with repetition, something else that we've covered in this class is looping. We have a bunch of different loops that we've used before. We've used the repeat loop when we have a task that we want to do a finite number of times. We have a forever loop when we want to just do something forever and ever and ever. We have a repeat until loop, which says go until a condition is met, usually because that condition is hard to predict. Otherwise, we would just use a normal repeater. There is a new 4th loop that I'm going to introduce you to. Down here in the bottom of the variable section, there's a loop called for each. What does for each do? Well, for each says, I want to go through a list and visit each item. While I'm visiting that item, I can refer to it as item. All right, so what does that mean? Well, let's say I want to, for each item in hamburger, okay, time to go get a list. For each item in Seahawks, let's go ahead and say the item that we are looking at right now. So I'm going to say item. And just to show you, I normally would just drag it right from the for each block right here. So when I click this, watch the sprite on the stage, watch what happens. It'll say Wilson, Wagner, Thomas, Wright, Clowney. So what it did is it went through every item in the list and decided and did something with it. Let's change things up a little bit. I'm going to make another variable, and I'm going to call it pi, for the mathematical constant pi. And I'm going to go ahead and set this aside for a second. Let us set the variable pi to the first few digits. Let's go with 3, 1, and 4. And I'm going to turn off the Seahawks just here for a second. Another use of the for each loop is maybe I want to get some information from the list. For example, if I wanted to get the sum, the added total of all the numbers in the list, how could I do it? Well, I'd probably want to save the progress of that number as I go through to add it. So I'm going to make a script variable called sum. This is just going to be a place that I add to figure out what the sum of all the numbers is. Just to make sure there's no mistakes, I'm going to go ahead and set sum to 0. I think the default for all defined variables is they all start at 0, but just to make sure that there's no mistakes anywhere, we're going to go ahead and leave that in there. Okay, so we're going to say script variable sum, set sum to 0. For each item in, we're no longer doing Seahawks. For each item in pi, let's go ahead and change sum by, you probably guessed it, by item. Okay, how do I translate this? What's going on here? Well, script variable sum says add to me, like use me as a place to store information. And then for each item in pi, I'm going to visit every location. In this case, there are 3 locations at index 1, 2, and 3. And when I get to each item, just add it to sum, change sum by that item. So the first time through, sum will be 3. Then it will be 4 because we will have added 1 to 3. Then it will be 8 because we will have added 4 to the last value of sum, which was 4. So if I go to print out the value of sum, if I did this correctly, boop, we get an 8. All right, so when we talk about traversing for reading or writing, this is what we're talking about. Well, what if I wanted to take all the values in a list and I wanted to, say, increase all of them by 1? You might think that you could just do something like this. Let's test the theory. Let's say, you know what? Change item by, oops, change not item. Oh, wait, will it let me do that? That would be amazing. Change item by 1. So I'm going to go ahead and, and we don't need sum anymore because our new job is simply to just change all the numbers in pi by 1. So when I click on this for each button, oh no, that is too bad. When I look at my list right here, it looks like nothing changed. And that is because when it comes to for each loops, they are for reading only. What do we mean by that? Well, for our purposes of programming, let's treat the for each loop like it can only get information from our lists. It can't provide any information to the list. If I want to do that, I have to have access to the index. I have to know what it is that I'm altering. And the for each loop kind of takes care of the index. It does all of that behind the scenes for me. So how do I design a loop that isn't a for each loop that's going to take care of this? All right, in comes the repeater. Now we're going to have to do more work here, but it's totally worth it. So let's talk about this. All right, I need to visit every element of pi. I've only provided 3 numbers here, but I could have just as easily have provided 10 or 50. So I want to be able to perform this task of visiting every number and increasing it by 1, no matter the size of the list. So let's use this. I'm going to repeat this task for length of hamburger. Which hamburger am I talking about? I'm talking about the pi hamburger, the pi list. So I want you to perform a task pi number of times. I want to be able to say change, let's see, is this what I want to do? Oh no, let's do it the other way. Let's say replace. I want to replace wherever I am in the list with the item that's in that list increased by 1. Well, here's the wrinkle. The first time through, this number is going to be 1. Then it's going to be 2. Then it's going to be 3. Seems like this is a number on its own that we need to track. So let's go ahead and grab a variable. And I'm going to call this variable index. And the reason I'm calling it index is it's going to be index's job to track where we are as we're looping through the list. So let's change index, not change, that's the wrong one. Can I relabel that? I can. Let's set index to 1. That's going to be the first place we look. All right. Then we say for every item in the list for length of pi, whether it's 3 items or 50. Replace, replace index of pi with, and then here's the kicker, buckle up, item, oh wait, hold on, let's go grab a couple things here real quick. Let's get everything we need, then we'll talk about it. I want to get the item that's at my current index, so I'm going to say item at index of pi plus 1. Whew. Okay, I know your head's probably spinning right now. Let's break down what this monstrosity is doing. Replace needs 3 things. It says, okay, where's the location I'm changing? The location in what list? And what value do you want me to change it with? Well, I need the value that's currently there. The value that's currently there is item index of pi. Hey, where are we and in what list? Okay, go get me the item that's there. Now, add 1 to it. Let's replace what was there with adding 1 to it. And because we resolve the innermost blocks first, it should process this before assigning the item, so it doesn't have like a conflict of information. Okay, so we're going to try this out. Declaring the index variable, setting it. Oh, you know what I've forgotten? We never changed. I knew I was missing something. We never changed index. Index was 1 and it has stayed 1. So what will happen is we're just going to end up adding, I think, a number to the very first index over and over. And there it is. Instead of, so we had 314. I was trying to add 1 to all of them. I was trying to get 425. Isn't that funny? But instead it just added 1 to the same index over and over. And the reason was index never changed. The first time through the loop, we needed index to be 1. But then we needed to be 2. And after that, we needed to be 3. And so on and so forth. So let's go ahead and change that. I'm going to say, look, change index by 1. After you perform your replacement, if index was 1, now it's 2. Now start your loop again and replace item 2 of pi with that item plus 1. And so on and so forth. So let's reset our list to 314. And let's click this button right here. Ba-doop. And there it is. We get 425. So let's contrast these 2 techniques for traversing a list. For each is undeniably easier. Man, oh man. It's just going to, if for each works for you, use it. We can both read or write with I'm going to call this an index loop. But the problem is it is complex. We have to manage the index ourselves. You're going to get convenience with the for each loop. You're going to get power with an indexing loop. Let's talk another example. What if I wanted to, remove every other item from a list, right? I cannot do that with a for each loop. That's just not something I can do. But I could do it with an index loop. And here's what that would look like. I'm going to detach this for a second so I can work. Every other item means I should probably, instead of changing index by 1, let's change index by 2. And we're going to talk about a problem we're going to introduce here in just a second. I'm also going to add some more numbers to my list. 3.14159. 3.14159. All right, that's plenty of numbers for right now. All right, now we don't need to know what the number is. We just need to delete it. So I'm going to get rid of this replace statement. I'm going to go get a deleter. I'm going to say, you know what? Just delete index of hamburger. What's my hamburger? We're talking about the list pi. And then update index by 2. So that we can go, we'll skip the number in front of me, and we'll proceed. All right, so I'm going to reset my list by using this setter block, okay? We got 6 values. If I really am successfully going to eliminate every other item, we should see the 3, the 4, and the 5 go away, and I think we're going to get just 119. But watch what happens. We ended up with 1459. All right, so what is going on here? Well, here's the issue. Whenever you delete something from your list, it will immediately update the index of all the variables. So I'm actually going to turn the stepper on so you can watch this thing work. See if you can catch it. I'm going to reset the pie list. There it goes. Sets all the pie list. Okay, watch the values that disappear when they disappear. So I'm going to go ahead and kick this off. So that's indexed to 1. It's going to delete our first item. And let's pause right here if I can catch it. Notice how index was 1. We deleted the first item. But now we've gone and added 2 to our index, which means instead of deleting the 4, which is what we want to delete, we've skipped from 1 to 3. So the fix here is I actually don't need to update index by 2, even though that logically makes sense, right? Like kill every other index. I want it deleted. Because the act of deleting moves all of the index numbers forward 1, we can actually just change this to a 1. So here, we're going to kill this execution, reset the list. So funny with the stepper on. Okay, 6 items here. We're going to watch this in slow motion, see if it does it. It should destroy the 3, then the 4, then the 5. All right, here we go. All right, index is 1. We destroy 3. Index is 2. We destroy 4. Index is 3. We destroy 5. And the reason it continues to work and work and work, think about this, is we said repeat over length of pi. Well, at the time that we started our loop, the length of pi was 6. So even though we were eliminating options, it felt the need to continue processing. So whenever it tries to delete an element that doesn't exist, I think there was a moment where our index was 4 and 5 and 6. There was nothing there for it to delete, and so it just failed to function. This brings up something important, which is you should be careful not to refer to an index that doesn't exist. A classic example of this is if you want to figure out the relationship between 2 elements that are next to each other, right? I think a famous one is called doubles. So the idea is I want you to search through the code and see if you can find anywhere where 2 numbers next to each other appear to be the same. And then how do we return that value? If I am searching for my index and index plus 1, and I see they're not the same, and then index goes up. So I compare the 3 and the 1. Whoops, stop. I compare the 3 and the 1, not the same. I compare the 1 and the 4, not the same. The 4 and the 1, not the same. The 1 and the 5, not the same. The 5 and the 9, not the same. But then if I don't stop my loop on time, if I loop too many times and go looking for an index that doesn't exist, like index 7, it can return an error. It can return false when maybe the answer should have been true. It can cause all kinds of issues. So be careful not to refer to an index that doesn't exist. All right, what if I want to make this block a little bit easier to use? Like delete every other element. Maybe there's an easier way to do that. There is. So in comes making a block. Hopefully you've worked with custom blocks before this video. But here's the gist of what we want to do. So this is a single command that we want to run that says delete every other block. So I'm going to say delete every other, not block, item in list is what I'm going to call this guy. Delete every other item in list. I'm going to click OK, and boom, we get this beautiful custom block screen. Very exciting. I'm going to go ahead and drag all of my pi variables out just so it doesn't get confused. Sometimes even if I name them the same, they think they are different variables. It's a little quirk of Snap. So I'm just going to make sure all of my old variables are out. Now I'm going to drag this code right in here, so that every time I click on the delete every item in list, it's going to execute that code for me. The problem is, if I look at the block right now, there's no way to specify, hey, what list am I talking about? So I'm going to go over here, and I'm going to change one of these words to not just be a label word. It's not just title text. It's going to be an input. And I'm going to specify what kind of an input I want. I don't want just a text or a number. I want to take a list. The word list, I'm expecting whoever programs with this custom block to give me a list. So we say delete every item in list. And this is what I drag into length of and delete index of, so on and so forth. So we'll say repeat length of list, delete index of list. Everything else indexed because it was a descriptive variable declared here. It doesn't need to change, so I'm just going to leave to declare the index, assign a value to the index, update the index. Click OK. This shows me my new custom block, and under the hood, there's some fanciness going on, but I've concealed that. And so now I can just set pi to the original number. I'm going to drag pi to this custom hamburger I cooked up myself. And now when I say delete every item in pi, I click it, and it goes through, and voila, it gets the job done. And check this out. I can just click it again, and it does the job again. So that is how to use custom blocks that take inputs as lists. I guess I have one last thing I want to show. Hang in there. Long video. You're doing great. What if we want some information from a block that we need it reported back? Like, for example, what if I wanted the first and last item in a list to be added up and reported back to me? Well, that's not just printing something or manipulating something. I need to be given information. And it's not true-false information. I need to be reported some information. So I'm going to say, okay, give me a reporter, and the name of this thing is going to be add first and last item in list. That's what I'm going to call this guy. It's going to be the job of this particular task, of this particular block. Let's go and ditch the other custom block for right now. You're going to notice a new block called report. We're going to talk about that in a second, but let's fix our custom block first, because right now its job is to report, but it doesn't know what list it's reporting on. So let's make sure this custom block takes a list as an input. Okay. And we're going to hit OK. All right, good. That updated. Excellent. Oh, and you know what I forgot to do? I forgot to specify that I don't want just any input. This needs to be a list. Okay. This report block is the block that conveys whatever is the answer, whatever is the result of your program. So if I were to say report 5 and I click on this thing, no matter what, it's going to report 5. If I say report spam, no matter what, it's going to report spam. But the job of this guy is going to be to get the first item and the last item in the list and add those together. All right, so this can actually be accomplished in a single statement. It's going to be a little clunky, but let's go to it. If I want to get the first item in my list, let's head back over to the variable category. So I'm going to refer to, where did you go, item? There we go. I want item first of my list. I want item last of my list. I want them added together. And I want that to be reported. So if I say, put this in right here, it's going to say, all right, what was my input list? Go get the first item of that list. Go get the last item of that list. Add them to the reporter and report that. All right, so I'm going to click OK. This has become a hamburger since I fixed the input type that it needs to be. I'm going to head over to my variables. I'm going to say, you know what? Add me the first and last item in pi. A little comical that we're trying to refer to the last item in pi, but I'll just refer to this pi right here that I've defined, in which case the first item is 3, the last item is 9. I click this, and I get 12. Voila. So in summary, we've talked about what lists are, how to add and remove items from those lists or replace items, the different types of values that can be held in those lists. We've talked about how to traverse lists, meaning visit all of the items in the list with either a for each loop or an index loop. We've talked about how to get lists to be inputs in our reporters so that we can actually use information, whether we are trying to delete every item in a list or report some information like adding the first and last item. And I think those are the advanced commands. All right, thanks for watching.